Hello viewers, in this video I'll continue with logarithms. Here I'll give a recap of how to use the log tables. Here I will also discuss about logarithms and antilogarithms. So in my previous video I have discussed about how to use log tables. The first step is we have to write the given number n in the standard form. Then we have to find the characteristic p. Then look for log m from the log tables and write log n is equal to p plus log m. Now what is characteristic p? Then what is mantissa, which is log m? All these I have discussed in my previous video. Here I will continue with the exercise questions. Now these are the log tables. I'll continue with the exercise questions. These are the questions from exercise 2.4 of chapter 2, Indices and Logarithms, from the book Applied Mathematics class 11 by M.L. Aggarwal. Evaluate the following using log tables. The sixth one, log of 0.00002591. So the first step is we have to find the characteristic. Here the characteristic is, since this number is less than 1, so the characteristic is 1 plus the number of zeros after the decimal point with a bar above. So the number of zeros after the decimal point is 1, 2, 3, 4 zeros. So 4 plus 1 is 5. The characteristic is bar 5. So log of this number is equal to bar 5 plus log of 2.591. Now we have to locate row number 25, column number 9. We have to see the number and then we have to locate in the same row the mean difference corresponding to 1 and we have to add that. So we will see row number 25 and column number 9. So this is the value 4133 and the mean difference corresponding to 1 is 2. So we have to add 4133 plus 2. So it is 4135. So this is equal to bar 5 plus 0.4135 or it is equal to bar 5.4135. So the log of the given number 0.00002591 is bar 5.4135. Then next question, log of 0.0000007324. So here the number of zeros is 1, 2, 3, 4, 5, 6, 7. So the characteristic is 1 plus the number of zeros after the decimal point. So it is bar 8. So the log of this number will be equal to bar 8 plus log of 7.324. This is the mantissa. Now we have to see row number 73 and column number 2. So this is row number 73 and under column 2 the value is 8645. Then the next digit is 4. So what we have to do, 8645, then the next digit is 4. In the same row 73 we have to locate the mean difference corresponding to column number 4. The mean difference corresponding to the column number 4 and row number 73 is 2. So it is 2. We have to add that 2. So if we add, we get 8647. So this is equal to bar 8 plus 0.8647. So this is bar 8.8647. So the log of this number is bar 8.8647. Now we will see the steps to find the antilogarithms. If log n is equal to x, then we can find n as antilog of x. How to find antilog? We will see. The first step is take the mantissa of log n and make sure it is positive. So here when we have log n, it will have the characteristic part and the mantissa part. We have to take the mantissa part and make sure it is positive. Then we have to use the antilog tables to find the value of this mantissa, that is log n. After using the antilog table, and if we say if the value is r, then we can convert it to the standard form. Using the characteristic p of log n, convert it into the standard form as n is equal to r into 10 raised to p. So the first step is we have to take the mantissa of log n and make sure it is positive. And then for this mantissa part, we have to use the antilog table and find its value. Let us say it is r. Then we can find the number n as r into 10 raised to p, where p is the characteristic of log n. So while doing problem, we will understand these steps. So similar to log tables, these are antilog tables, except that in the first column there are numbers like 0.00, 0.01, 0.02 up to etc. 0.49, then 0.5, 0.51, 0.52 up to etc. 0.99. Then we have the remaining 10 columns corresponding to the digits 0, 1, 2 up to etc. 9, and then the mean difference column with the numbers 1, 2, 3 up to 9. We'll see an example question. Find x if log x is equal to 2.7758. So if x is, we have to find x if log x is equal to 2.7758. So given log x is 2.58, so from this we can write x is equal to antilog of 2.7758. So the first step is we have to see whether the mantissa is positive. So here the mantissa is positive, so we can proceed. So this is nothing but it is antilog of 0.7758 into 10 raised to 2. So this is how we have to write. We have to find the antilog of the mantissa part into 10 raised to the characteristic, which is 2. So now we will find antilog of 0.7758. So here this is 0.77. We have to look for row number row 0.77 and column 5. So this is row 0.77 and under column 5 the corresponding value is 5957. So it is 5957. Then plus the next digit is 8. So in the same row 0.77, we have to look for the mean difference under column number 8. So it is 11. So 5957 plus 11. So it is 5968. So this is equal to, antilog of this is nothing but 5.968 into 10 square. Now 5.968 into 10 square is nothing but it is 100. So 5.968 into 100 is 596.8. So this is x. The next question. These are the questions from exercise 2.4 using antilog tables. Find x. First subdivision, log x is equal to 1.3649. So here again the first step we have to check whether the mantissa part is positive. So it is positive. So from this we can find x as antilog of 0.3649 into 10 raised to 1. So this is equal to, so we have to look for row number 0.36 and column number 4. So this is row 0.36 and the corresponding column 4, the value is 2312, and then we have to add the mean difference in the same row corresponding to column number 9. So it is 5. So 2312 plus 5 is 2312 plus 5. So it is 2317. So antilog of 0.3649 is 2.317. Then here we have into 10 raised to 1. So into 10 raised to 1 is 10. So x is 23.17. The next question, log x is equal to 2.5179. So here if log x is 2.79, so from this we can write x is equal to antilog of 0.5179 into 10 square. So now we have to look into row 0.51 and column 7. So row 0.51 and column 7, the corresponding value is 3289. Then we have to add in the mean difference corresponding to the next digit. Next digit is 9, corresponding to 9 in the same row. So it is 3289 plus 7. So 3289 plus 7, it is 3276. So this is equal to 3.3296. So this is equal to 3.296 into 10 square, or this is equal to 329.6. The next one, log x is equal to 4.8291. So from this we can write x is equal to antilog of 0.8291 into 10 raised to 4. So this is equal to antilog of 0.8291. We have to look into row number 0.82 and column number 9. The corresponding value is 6745. Then in the same row we have to add the mean difference corresponding to the next digit. Next digit is 1. So in the same row number 82, mean difference corresponding to 1 is 2. So 6745 plus 2, it is 6747. So this is equal to 6.747 into 10 raised to 4. 10 raised to 4 is 10,000. So 6.747 into 10,000 will be 67470. The next question, log x is equal to bar 2.4567. So here log x is bar 4567. From this we have to calculate x. So here we have to see the mantissa part whether it is positive or not. This mantissa part is positive. So we can write x is equal to antilog of 0.4567 into 10 raised to minus 2. Here the characteristic is bar 2, which is nothing but minus 2. So this is equal to, now antilog of 0.4567 will be, we have to see row number 0.45 and column number 6, and the corresponding value is 2858. Then we have to see the mean difference corresponding to the next digit, which is 7. So it is 5. So 2858 plus 5. So it is 2.863 into 10 raised to minus 2. Now 2.863 into 10 raised to minus 2 is nothing but it is 0.02863. The next question, log x is equal to bar 4.6501. So from this we can write x is equal to antilog of 0.6501 into 10 raised to minus 4. Now we have to see row 0.65 and column 0. The corresponding value is 4467. Then add the mean difference corresponding to the next digit. So it is 1. So it is 4.467 plus 1, 4.468. So this is 4.468 into 10 raised to minus 4. This is nothing but it is, if it is 10 raised to minus 4, then after decimal point we should have 3 zeros. So it is 0.0004468. Now coming to the next question, log x is equal to minus 2.1304. Here it is given minus 2.1304, which means this is minus 2 minus 0.1304. So let us recall the steps. The first step is we have to take the mantissa of log n and make sure it is positive. Here if we see this mantissa part, it is not positive, or this is equal to minus 2 minus 0.1304. So we have to make this mantissa part as positive. So for that I am subtracting and adding 1. So when we do this, here we will have minus 2 minus 1, which is minus 3. Then here we will have plus 1 minus 0.1304. Now 1 minus 0.1304 is nothing but it is plus 0.8696. Now this mantissa part is positive and only the characteristic is negative. Now we can find the antilog. So x is equal to antilog of bar 3.8696. So this is equal to antilog of 0.8696 into 10 raised to minus 3. So now we can see the antilog tables. So here if we see, we have to look for row 0.86. This is row 0.86 and column 9. So the corresponding value is 7396 and add the mean difference corresponding to the next digit, which is 6. So it is 7396 plus 10. So it is 7.406 into 10 raised to minus 3. Here if we have 10 raised to minus 3, it means we should have 2 zeros after the point. So it is 0.007406. So this is x.